relatively easy for our team to tune a version of Llama 4 Maverick that basically was way at the top. Whereas the one that we released, that's the kind of the pure model, actually has no tuning for that at all, so it's further down. So I think you just need to be careful with some of the benchmarks, and we're gonna index primarily on the products.
Do you feel like there is some benchmark which captures what you see as a North Star of value to the user, which can be sort of objectively measured between the different models, and you're like, I need Llama 4 to come out on top on this?
Well, I mean, our benchmark is basically user value in Meta AI, right? So it's
you can't compare other models.
Well, we might be able to, because we might be able to run other models in that and be able to tell. And I think that that's one of the advantages of open source is basically you have a good community of folks who can like poke holes at, okay, where is your model not good and where is it good? But I think the reality at this point is that all of these models are optimized for slightly different mixes of things. I mean, everyone is trying to, I think, go towards the same. I think all the leading labs are trying to create general intelligence, right? And super intelligence, whatever you call it, right? Like basically AI that can lead towards a world of abundance where like everyone has these superhuman tools to create whatever they want, and that leads to just dramatically empowering people and creating all these economic benefits. I think that that's sort of, however you define that, I think that that's kind of what a lot of the labs are going for. And, but there's no doubt that different folks have sort of optimized towards different things. I think the Anthropic folks have really focused on kind of coding and agents around that. You know, the OpenAI folks, I think, have gone a little more towards reasoning recently. And I think that there is a space which, if I had to guess, I think will end up probably being the most used one, which is quick, is very natural to interact with, is very natively multimodal, that fits into kind of throughout your day the ways that you want to interact with it. And I think you got a chance to play around with the new Meta AI app that we're releasing. And you know, one of the fun things that we put in there is the demo for the full duplex voice. And it's early, right? I mean, it's not. There's a reason why we haven't made that the default voice model in the app, but there's something about how naturally conversational it is that I think is just like really fun and compelling. And I think being able to mix kind of that in with the right personalization is going to lead towards a product experience where, you know, I would basically just guess that you go forward a few years, like we're just going to be talking to AI throughout the day about different things that we're wondering. And, it's like you'll have your phone, you'll talk to it on your phone, you'll talk to it while you're browsing your feed apps, it'll give you context about different stuff, you'll be able to answer questions, it'll help you as you're interacting with people in messaging apps. Eventually I think we'll walk through our daily lives and we'll either have glasses or other kinds of AI devices and just be able to kind of seamlessly interact with it all day long. So I think that's kind of the North Star, and whatever the benchmarks are that lead towards people feeling like the quality is like that's what they want to interact with. That I think is actually the thing that is ultimately going to matter the most to us.
I got a chance to play around with both Orion and also the Meta AI app, and the voice mode was super smooth. It was quite impressive. On the point of what the different labs are optimizing for, to steelman their view, I think a lot of them think that once you fully automate software engineering and AI research, then you can kick off an intelligence explosion where you have millions of copies of these software engineers replicating the research that happened between Llama 1 and Llama 4. That scale of improvement, again, in the matter of weeks or months rather than years. And so it really matters to just close the loop on the software engineer, and then you can be the first to ASI. What do you make of that?
Well, I mean, I personally think that's pretty compelling. And that's why we have a big coding effort too. I mean, we're working on a number of coding agents inside Meta, because we're not really an enterprise software company. We're primarily building it for ourselves. So so again, we go kind of like for the specific goal. We're not trying to build a general developer tool. We're trying to build a coding agent and an AI research agent that basically advances Llama research specifically. And it's like just fully kind of plugged into our tool chain and all this. So I think that that's important. And and I think is going to end up being an important part of how this stuff gets done. I would guess that like sometime in the next 12 to 18 months, we'll reach the point where like most of the code that's going towards these efforts is written by AI. And I don't mean like autocomplete. I mean, right today you have kind of, good autocomplete, like you start writing something and it can complete the kind of section of code. I'm talking more like you give it a goal, it can run tests, right? It can kind of improve things. It can find issues. It writes higher quality code than like the average very good person on the team already. And like I think that's going to be a really important part of this for sure. But I don't know if that's the whole game. I mean, I think that I think is going to be a big industry. And I think that that's going to be an important part of how AI gets developed. But I think that there are still guys. I mean, look, I guess one way to think about this is a massive space, right? So I don't think that there's just going to be like one company with one optimization function that serves everyone as best as possible. I think that there are a bunch of different labs that are going to be doing leading work towards different domains. Some are going to be more kind of enterprise focused or coding focused. Some are going to be more productivity focused. Some are going to be more social or entertainment focused. Within the assistant space, I think there are going to be some that are much more kind of informational or productivity. Some are going to be more companion focused. It's going to be a lot of the stuff that's just like fun and entertaining and like shows up in your feed. And I think so I think that there's just like a huge amount of space. And part of what's fun about this is like, it's like going towards this AGI future, there are a bunch of common threads for what needs to get invented, but there are a lot of things at the end of the day that need to get created. And I think that's, I think you'll start to see a little more specialization between the groups if I had to guess.
It's really interesting to me that you basically agree with the premise that there will be an intelligence explosion and something like superintelligence on the other end. But then if that's the case, or tell me if I'm misunderstanding you, if that's the case, why even bother with personal assistance and whatever? Why not just get to superhuman intelligence first and then deal with everything else later?
Well, I think that's just one aspect of the flywheel, right? So part of what I generally disagree with on the fast takeoff thing is it takes time to build out physical infrastructure, right? So if you want to build like a gigawatt cluster of compute, that just is going to take some time, right? It like takes NVIDIA a bunch of time to like stabilize their new generation of the systems, and then you need to figure out the networking around it, and then you need to like build the building, you need to get permitting, and you need to get the energy, and then like, okay, you want like some, whether it's gas turbines or green energy, you need to like, there's a whole supply chain of that stuff. So I think that there's like a lot of, and we talked about this a bunch on the last time that I was on the podcast with you, and I think some of these are just like physical world, human time things that as you start getting more intelligence in one part of the stack, you'll basically just run into a different set of bottlenecks. I mean, that's sort of the way that engineering always works. It's like you solve one bottleneck, you get another bottleneck.
Yeah.
Another bottleneck in the system, or another ingredient that's going to make this like work well, is basically people getting used to and learning and having a feedback loop with using the system. So I don't think like these systems don't tend to be the type of thing where like something just shows up fully formed and then people magically fully know how to use it. And that's the end. I think that there is this coevolution that happens where people are learning how to best use these AI assistants. On the same side, the AI assistants are learning what those people care about, and the developers of those AI assistants are able to make the kind of AI assistants better. And then you're also building up this base of context. So now you wake up and you're like a year or two into it, and now the AI assistant can reference things that you talked about a couple of years ago, and like that's pretty cool. But you couldn't do that if you just launched the perfect thing on day one. There's no way that it could reference what you talked about 2 years ago if it didn't exist 2 years ago. So I guess my view is like there's this huge intelligence growth. There's a very rapid curve on the uptake of people interacting with the AI assistants and like the learning feedback and kind of data flywheel around that. And then there is also the build out of the supply chains and infrastructure and regulatory frameworks to enable the scaling of a lot of the physical infrastructure. But I think at some level, all of those are going to be necessary and not just the coding piece. I guess one specific example of this that I think is interesting, actually, even if you go back a few years ago, we had a project on, I think it was on our ads team, to automate ranking experiments, right? That's like a pretty constrained environment. It's not like write open-ended code. It's basically look at the whole history of the company, every experiment that any engineer has ever done in the ad system, and look at what worked, what didn't, what the results of those were, and basically formulate new hypotheses for different tests that we should run that could improve the performance of the ad system. And what we basically found was we were bottlenecked on compute to run tests based on the number of hypotheses. It turns out even with just the humans that we have right now on the ads team, we already have more good ideas to test than you actually have either kind of compute or really cohorts of people to test them with, right? Because I mean, even if you have like 3.5 billion people using your products, you still want each test needs to be statistically significant. So it needs to have, some number of whatever it is, hundreds of thousands or millions of people. And it's there's kind of only so much throughput that you can get on testing through that. So we're already at the point, even with just like the people we have, that that we already can't really test everything that we want. So now, just being able to test more things is not necessarily going to be additive to that. We need to get to the point where the average quality of the hypotheses that the AI is generating is better than what all the things above the line that we're actually able to test that like sort of the best humans on the team have been able to do before it'll even be marginally useful for it. So I think that there's like, we'll get there. We'll get there, I think, pretty quickly. But it's not like, okay, cool, the thing can write code, all of a sudden everything is just improving massively. There are like these real world constraints that basically it needs to be able to kind of do a reasonable job. Then it needs to you need to have the compute and the kind of people to test. And then over time, as the quality creeps up, I don't know, are we here in like 5 or 10 years and it's like no set of people can generate a hypothesis as good as the AI system? I don't know, maybe, right? It's like, then I think in that world, obviously, that's going to be how all the value is created. But that's not the first step.
Publicly available data is running out. So major AI labs like Meta, Google DeepMind, and OpenAI all partner with Scale to push the boundaries of what's possible. Through Scale's Data Foundry, major labs get access to high-quality data to fuel post-training, including advanced reasoning capabilities. Scale's research team SEAL is creating the foundations for integrating advanced AI into society through practical AI safety frameworks and public leaderboards around safety and alignment. Their latest leaderboards include Humanities Last Exam, Enigma Eval, Multi-Challenge, and Vista, which test a range of capabilities from expert-level reasoning to